Dear students, I am happy to welcome you all to the course on Statistical Methods for Psychological Research Part 2. In this lesson, we are going to learn hypothesis testing for categorical variables and inference about frequencies. First, you will be learning about the concept of sample and population and its need. Then you will be going on with the procedure for testing a hypothesis. Then you can write the null and alternative hypothesis on the problem according to your study. Then you can provide your statistical inference on the sample and the population based on testing of hypothesis. Now let us start with our first part of our lesson, that is on objectives, sample and parent population under testing. Population and sample. Let us see this picture here. Here this is a population which is representing a group of individuals, which is a collection meant for a particular study. So here you can see the sample which has been collected from this population, which is nothing but a subpart, or you can call it as a subset obtained from this population. Now in the second image you can see a group of fruits here, which I can meant as a population again, but here I am choosing two different samples. One you can see as a random sample, the other you can see as a non-random sample, where here in a non-random sample the same type of fruit has been selected a lot. So hence I can call it as a biased sample. Similarly, in a random sample you can see a variety of fruits has been selected here, which I can mention it as an unbiased sample. Now we can go for the technical definition for the population and sample. The population consists of all possible individuals or items that share certain characteristics of interest. In statistics, a sample refers to a subset of individuals or items selected from a larger group known as population. Let us see some examples on these sample and population. Blood test, study on the quality of a product, drug testing, exit polls results of an election. In a blood test, in our real time we will be moving towards the hospitals for giving a sample of blood. Similarly, in a quality of a product, a manufacturer will decide the quality of a product based on its specifications, how the product length to be, breadth to be, or its height to be. He will decide based upon the sample on the quality. Then coming on to the drug testing, very recently we went with our COVID situation, where we have went with the vaccination. So there they went with the samples to test the vaccinations, how it will works for the disease. Then they went with the market for the drug testing. At the end, the exit polls results of an election. So when the election has been completed, you will be taken a poll from the sample of a population, and they will decide about the results. In the drug testing, recently we went with the COVID, where the vaccination has been tested for samples and they have been decided into the market. Similarly, exit poll results of an election. Once the election has been completed, the sample will be collected on the decisions of the people who has been voted, then they will be releasing the results of exit poll. Next, the sample is chosen to represent the population to make inferences or draw conclusions about the population based on the observed sample data. Sampling is often used when it is impractical or impossible to study the entire population due to factors such as time, cost, or logistical constraints. Here, the representation of a sample, earlier we have been discussed about the examples like blood test, like drug testing, that is it will be a representation towards your population. So the blood test, you have been giving a sample which decides your total blood report. That is what I am meaning it as, an sample is chosen to represent. Similarly, the impractical situations is nothing but you cannot move towards your entire population due to the reasons as time constraint, at the same time cost constraint or logistical constraints. By studying a smaller sample, researchers will aim to gather information that can be generalized to larger population. A sample is considered representative when it accurately reflects the characteristics and diversity of the population which has been drawn from. Now, the generalization is nothing but here, as in a mathematical format, how you can generalize your values. Here also you can move on with the based on the sample, you will be moving for the generalization of population. In the similarly, where you have been drawn from the population, the characteristics has to be matched properly. The process of selecting a representative sample involves employing various sampling techniques to minimize the bias and ensure that each member of the population has an equal chance of being included in the sample. The accuracy of conclusions drawn from a sample depends on factors such as the size of the sample, the sampling method used, and the variability within the population. So, as I mentioned that you should have the equal chance of selecting a sample from the population. You may not be biased towards it, that is, as like in our previous example, you may not biasedly choose your fruits. Similarly, the size of the sample will also decides you how you are going to present your results, that is, as like in a small sample or in a large sample. It means that your size of the sample will decides your accuracy of results, how you are going to present. Statistical techniques are applied to the sample data to estimate the parameters and make inferences about population as a whole. It is important to note that the sample should be selected to minimum bias and represents the accuracy of the population of interest to obtain the reliable results. Additionally, the sample size should be appropriate to ensure an acceptable level of precision in the estimates made about the population. So, as I mentioned here, your parameters will be estimated through your samples and population here, and I can make you a clarity here. A parameter will be the statistical measure based on population units or observations. Similarly, statistic or sample statistic is a statistical measure based only on the sample. Usually, when you are collecting a sample or when you are having a population, you have to consolidate, that is, you need to have a single set of number that you are calling it as an statistical measures, that is mean, standard deviation, variance, proportion. So, it may be considered for the sample or it may be considered for the population, and you may denote with different symbols here, that mu as your population mean, similarly x bar as your sample mean. So, here your mu will speaks about a population parameter, x bar will speaks about the statistic parameter here. Similarly, sigma will speaks about the population standard deviation, similarly s will speaks about your sample standard deviation, and small p will speaks about your population proportion, and p cap will presents your sample proportion. That is, here when you need to consolidate the values of the sample and the population, you are representing them as the statistical measures, as like here your mu, sigma and p. Now, we come to the end of part 1. Here we learnt sample and population definition and its respective need. Similarly, how you are measuring it as an statistical measures, that is consolidated part, sample mean and population mean. I am confident that you understood all the concepts which we covered in part 1. We will continue in the next video. Thank you.